so we're going to look at the refraction problems that are from your book. And the first one says you place a waterproof laser and glass prism flat on the bottom of an aquarium, as shown in the following. So I recreated that image. The light leaving the prism when there's no water in the aquarium follows path B. If we filled the entire aquarium with water, which path would the light leaving the prism now follow? So let's first just make sure we understand why it follows path B, and then see what happens if we change the medium, that material that the light is traveling through. So here I am in a prism, a glass prism. It has a high density. And as the light is within that high density, it's traveling in a straight line, and then it goes from an area of high optical density to an area of low density. So if this is air and this is our prism, so it's glass, we know that the N of glass, the index of refraction, is greater than that of air. So the index of refraction of glass is greater than that of air. So when light is traveling from an area of high density to an area of low density, high N to low N, we get refraction from high to low away from the normal. Okay, so as light travels from high to low, it's going to bend away from the normal. Now the normal would be perpendicular to this surface, and it'll bend away from that normal. Now we're told it bends along B. So the other part that influences how much bending occurs, we said was twofold. One was the angle of incidence. And regardless of whether this is in air in the bottom of the aquarium or I fill that aquarium up with water, the angle of incidence is going to be the same. The light is still traveling through that prism and intersecting that boundary in the same angle. The other effect on how much bending occurs are the difference between the two mediums. So keeping in mind the two mediums, in this case we have prism, glass, and the air. If I fill the aquarium up with water, then my two mediums become prism, the glass, and water. So the difference between glass and air is greater than the difference, and this is of our index of refraction, between glass and water. The larger the difference, the larger the bending. Remember, oops, forgot an E. So bigger difference, bigger bending. All right, so now if I put water into the aquarium, I have a smaller difference between the glass, that medium, the medium of incidence, and the refracted medium. And so with a smaller difference, I'll get less bending, and C will more likely be my line. All right, a couple of ideas there. Not only the idea of how bending occurs and what's important in that bending, which way it goes, but that idea of the difference in the medium. Okay, good job.